Hello everyone, welcome back to the CAE-SHOP channel. In this video, I would like to introduce to you how to perform the wear simulation problem using Workbench LS DYNA. Workbench LS DYNA will be used for pre-processing purpose, including building the assembly, setting boundary conditions, and wear model. Then, LS report will be used to read and display the wear result. You can refer to more information in this file. Here you can see or find many information. Here some contact model are support for the wear problem, such as the automatic survey to survey, forming survey to survey, automatic single survey, and forming one-way survey to survey. Other requirements such as the SPR or MPR need to set value to 1 to specify the slave or matter will be recorded in the where result. A keyword contact where is to define the Archard Wear model parameter, including here is a K, is a wear coefficient, SS and SM is a hardness of material for the slave on matter side. In the next, to record the wear depth and sliding distance, you will need to set n wear a value greater than 0 in the database extend import. Okay, so a simple model will be used in this introduction. Let's start do it. In the workbench, create a new LS DYNA analysis. Right-click on Geometry cell to open Design Modeler. Unit millimeter, and in the XY plane, a simple geometry is two rectangles. The length at the bottom is 30 mm. The height equal to, on the top is the same 2 in the height, and the length equal 10. Extrude operation and the depth equal 5 mm. Okay, generate. So we will have two body. I will rename to the bottom and top. Close the close the design ruler. I will use the default material, in this case is a structural steel. So you need, when you want to use another material, you can define in the engineering data. In this case, I use the default structural steel. Double click on the model cell to open the mechanical window. In this problem, the contact region need to define in the LS DYNA environment here. So I will delete all items in the connection brand. Right. So I will delete contact and delete body interaction. Map I will define element size equal 1. The next in the analytic and time equal 0.01 second. In the student version, the processing time needs to add MP and solver precision is a double. I will define some boundary condition. Fixed support at the bottom. And the next is the movement of the top body in the X direction. Here equal 20 millimeter. And in the Y and Z equal, in the Y is 3 and in the Z equals 0. The pressure on the top face equal 10 megapascal. So now we need to define the contact region between two bodies. In the Add-on tab, click on keyword monitor to active. Back to the environment and click on keyword monitor. In the keyword monitor, I will define a contact automatic survey to survey. Contact automatic survey to survey. Add. So we need to define the title of contact. Here, example, contact wear. Slave and matter. Matter is the face of bottom body and high is the bottom. I select the bottom face as the top for the slave. Static and dynamic coefficient of friction is the same, 0.1. 0.1. As a control, keep as default. Here, we will have two options. Either include slave size in the database and fork. Here, to include the wear design on the slave, we need to change it to same as 1, but also add initial contact wear to DYNA file. So if you only want to the wear design on the slave, you only need to set the slave option here and keep as default for matter. In this case, I want to get the result, the wear design on the both slave and matter. So I will change for the matter size same as 1, but also add initial contact wear. Okay, so the wear design will be recorded on the both slave and matter side. The next, we need to define the wear model. Here the keyword is the contact. add wear. In the contact add wear, the first is the contact interface. We need to select the contact already defined. Here is the contact automatic, surface to surface. The wear law equals 0. Default is 0. Here equals 0. The software will use the Archard Wear model. The next is the 3 parameters. The first is the wear coefficient. The second is the hardness material. And the third is also hardware material. In this, the second parameter is the hardness material in the slave side, and the third for the master side. And one important thing here is the unit system is the NMM. So the hardness material in the stretch unit, it means megapascal. So here I will define the first is the wear coefficient 1e minus 6, and the hardness of the both slave and master equal 1 megapascal. Another keep as default. The next, to write the wear result into DYNA file, we need a keyword here. Is the interface LS interface spring back LS DYNA. With this keyword, result of wear result will be written in the DYNA in file. Here's scoping method. We don't need to use it, so set to not use it. Cat optional. From default is no. We need change to yes. And number process cycle equal 1. If we relate to the CAE, you want to perform many cycles of the load. And the last keyword when we use it to record wear result. Is a database extend info for and here is a cat tool. You will have output contact wear data. Default is no, so you can change to wear dip or both wear dip and sliding distance. So here I will use both wear dip and sliding distance. Okay, so everything is enough. So we can solve the problem now. After the solution finished, you can reach some result is deformation and stretch. Close the keyword monitor and show own body. The next, to reach the wear design, we need to use the LS pre-put. Right-click on the solution brand. Open solver file directory. Here, you will have the input.import file. Copy. Now open LS pre-put. Ctrl B to import result file. And open the input.import file. In this file, it only saves result on the contact face. Here's the bolt, finger component. In the node, you will have contact depth and wear sliding distance. Here is a sliding distance. And the wear depth result. You can see on the one side. Here is on the master side. And the slave side. The master also result interface pressure. Okay, so in this video, I have introduced a way to define the Archard Wear model using Workbench LS DYNA. Workbench LS DYNA is only the pre-processing. To evaluate results, you will still need to use the LS pre-put. If you like, please like, share, and subscribe for the more useful video. Thank you.